today I will be speaking about AI and machine learning in products and also how it is useful for product managers. I will be speaking, let's say, partially about topics that are absolutely not technical. You don't need any programming knowledge at all. But also, I will be speaking about topics that might require some tech knowledge, but I'll be showing you what is possible. And potentially, if you have any developers you work with, they might help you to utilize those things. But at least the first half require absolutely no programming knowledge at all. Okay, so just shortly about me. My name is Jiří Knessel. I'm from the Czech Republic, even when I'm living in English-speaking countries well over a decade. I have started a software development company called Flexiana. We have a product. I will be speaking about this just as an example today, but I will try to minimize this to the bare minimum that is related to machine learning and AI. I have been programming for over 3 decades, basically since childhood. Since university, I've been in mathematical optimization, mainly tasks related to optimizations in manufacturing, logistics, warehouses, and so on. About 15 years ago, I have been involved in the first machine learning project, and more than 2 years ago, I was building first application using large language models. Back then, it was GPT-3. So I've been building applications for LLM over 2 years. Yeah. Prior working in my company, I worked as a CTO in a couple of companies. I was also teaching software architecture, best habits for software developers. I was a mentor in a couple of startup accelerators. But let's jump to the topic for today. Okay, so I'll cover a couple of areas that are relevant. So if you are a person who is responsible for the product, be it a product manager or you have a startup, you are responsible for a product in the company. It might be external product, it might be internal system. You need to do a couple of activities. First one is the research. So I'll show you how to generate ideas and how, in this case, I'll not be speaking only about large language models. We will cover plenty of topics related to machine learning. How can you use large language models like DeepSeek, ChatGPT for idea generation? Like what might be a successful product? What might be a successful system or new feature? Once you have an idea for a product or you already know what you will be building, you need to know what features to build. So I'll be speaking about how to do feature mapping, how can you parallelize yourself with AI. Then once you form the idea and you know what you want to build, you also need to manage the team. You need to explain developers, designers, testers, and other people in the team what to build and what is more important, what's less important. So we will quickly jump into this, and then we will speak about the next topic. I think this will be a little bit more technical, but I'll try to keep this as friendly and as let's say business friendly and non-technical as possible. And it is how to embed machine learning into your products. We will be speaking about different types of machine learning. This field is very, very wide. So I'll cover just a few examples, but I will show you how those things work and how they can help you. Then we will quickly speak about what I believe we might see in the future. And then just a couple of quick takeaways. I'll give you a couple of examples and that's it. Okay, I have seen, yeah, we have a photo, we have a question. If it's being recorded and if you will get an access. Yes, it is being recorded. We have a YouTube channel, youtube.com/flexianadev. The link will be on the last slide, so get it. Okay, so let's start with idea generation. I believe there are two great ways how to come up with ideas for new products. First one is looking for, let's say, industries that has low net promoter score. Net promoter score is more or less a metric that shows how success, let's say, how is the company perceived and if it's liked in that market or not. So when you look at certain markets, for example, banks, telecommunication companies, industries like this very often have very low net promoter score. So, for example, in the Czech Republic, where I am from, there is a successful bank, let's say in top 10, called Airbank. And this is a good example. So back then in the Czech Republic, there was no single bank with net promoter score larger than 0, which is really terrible. Basically, you want to have 50 plus. The scale is -100 to +100. And back then, basically all banks had 0 or less, which means there was no single bank people liked. And they came up with an idea, let's do a simple bank. Let's make the contract very, very short. Yes, I can share the presentation. I'll add the link to the YouTube video. So they started a bank with the only objective having high net promoter score. So they have a very simple contract. You can't see the presentation. That's weird. 1 second. Share. Okay. Okay. Sorry. Can you see it now? Okay. Okay. Sorry for that. Sorry for that. So let's continue. And now, the disadvantage of large language models is that they have certain cutoff, which means, for example, some large language models might have a cutoff of, let's say, October 2023. However, you can always, you don't get that many disruptive startups in various fields. So what you could do, you can ask ChatGPT and other LLMs to give you a list of industries that have low net promoter score, and there are 0 companies with high net promoter score. There are no love brands in given markets. You can drill down to certain niche, which is your specialty, or a location. So you might say, okay, you are in the UK. So are there any insurance companies in the UK that have high net promoter score? I would be surprised, honestly. And then this gives you an opportunity. And a good thing about technologies, when I started with technologies decades ago, applications were ugly, terrible. Basically, if you remember the times of DOS operating system, everything was just black background, white text, more or less, or blue background. Then we got Windows 3, Windows 95. Applications were still ugly, but people were using them because it was enabling new things. Now we live in a time where we have UX, we have usability testing. It's more difficult to just come up with a new technology. However, new technologies like generative AI gives you new possibilities. And generative AI, robotics, potentially new materials, all of them enable new use cases, which allows you to disrupt those industries. So basically, those language models are great to give you new ideas for new products. The second great way how you could generate ideas for new products, new companies, is one thing. So there are so-called Worldly maps. These are used to mapping the experience of the business, how the customer, what the customer see. So on the top is what is more visible, on the bottom what is invisible to customers. But what is more important for us today is evolution axis. And evolution axis says once something new exists, genesis phase, you can beat this market by creating custom products. If there is a market where everything is a custom product, you can turn it into a product for everybody. And once it's a product for everybody, you can turn it to commodity. So every time you see something that is built for each customer, and you think, okay, can I turn this into a product that will not cost $20,000, but will cost $200? You can take the whole market. And again, you can use large language models to brainstorm ideas, which helps a lot. And again, ideally, you need to look at new possibilities, which might be, for example, AI or other forms of machine learning, but it might be any new technology that is available to you. And basically, every time you spot something where Genesis means only the government, only the army, only the billionaires can afford this, okay, can I turn this to be something for enterprises, for millionaires? Can I turn this for small businesses and normal people? That's a good way how to generate ideas. Let's continue to how you can, once you have an idea, as a product manager, you need to turn this idea into a list of features and you need to prioritize them. So when you prioritize features, I use a model. It's ancient model used for maybe 4 decades. It's called Kano model. And it is done that you list all the features that you believe or you find out that should be in the product. You should speaking with potential customers and generate many ideas, probably more than you will ever have in your product. And then in Kano model, you have a way how to categorize all of those ideas. So first thing is to each persona, because each persona in your product might have different needs. So imagine you have accounting system. So a bookkeeper has different needs than a financial manager, who has a different needs than, for example, server administrator or basically sysadmin in the company. And for each feature and for each persona, you are asking 2 questions. First question is, what would you do if the feature was not implemented? And then you ask, what would you do if the feature was implemented? And in Kano model, you have these categories. So basic needs are must-have things. So if your subject you are speaking with, the persona says, without this feature, I'm not going to use the product. And if the feature is present, I really expect it. So like in car, you expect brakes, right? So it's a must-have thing or basic need. And every time you are building a product, you must include all basic needs or must-haves in your product. And those must-haves might be different for different personas. So you need to ask all personas. Then there are performance needs. So performance needs are, when it's not present, it is, let's say, bad, but you can live without that. And if it's there, you like it, which I would say adaptive cruise control in the car would be such a performance need. It improves the experience, but still you could survive and have a car without adaptive cruise control. And then there are the lighters. So the lighters are, if it's not present, I don't really care. but if it's there, I like it. These might be, for example, when you kick under the trunk and it opens. So these are the lighters. And these in the list of priorities are the third level. Then in this chart, I don't have a graph, I don't have it, but there is also detractors and neutral. Detractors are things that actually users don't like. And neutral means when they don't care if it's implemented or not implemented. If all of your personas are indifferent to, let's say, certain feature, you can easily delete it. And you know that you can release the product only when all basic needs are met. Now, the thing is, I have done kind of model mapping a couple of times. And when you imagine you have, let's say, 100 potential features, you really want to evaluate more features than you will have in your product. And you have 5, 7 personas, you easily can have hundreds of questions. And you need to ideally get the persona on some chat, speak, explain the feature, collect the feedback, and then once you're done, you need to evaluate all this, prioritize all this. And it will take you days to get to, let's say, this is the minimal product, these are all must-have features, these are performance features. So let's say this looks like a good set of features we should have in this product. With AI, you can actually automate both phases. First phase or 3, you can automate generating ideas for features. You can let users to chat with your model. This model will be storing the answers, and then you can ask LLMs to evaluate and prioritize. And it works great. I remember back in the day when we had, let's say, 2,000 or 4,000 tokens, this would be unthinkable. But now you can easily have tens of thousands of tokens. And token is let's say, almost a letter. So you can fit a whole book into the context which the AI is holding. So you put in the specification, you put in answers for all personas, which means all examples of given personas. And this model will give you perfectly prioritized list and will give you explanation of what personas need this. So you know, okay, this feature is needed by everybody, we should build this first, and so on. So this is kind of model. Now you have got the list of features, and you need to split it to tasks. You need to show how it will look like. So there are a couple of tools I would like to show you today. So first one is, this one, it's prompt that has been like older than 2 years. I wrote it in the tool I wrote for product managers internally for us more than 2 years ago. So basically, you can write a prompt, give it the specification, give it a list of features. You can ask it to give a certain number of user stories, and it gives you a list of user stories that you can put to any software you use to manage developers. The next thing, and it is a bit more technical, but still, I'll try my best. So basically, there is something called behavior-driven development, which means that in development of new products, you have specifications that are runnable tests. So you specify, for example, the initial situation, the user is on this screen, fills this form, then the action, so the user submits the form, and then there is the outcome. So for example, you get a file to be downloaded, you get an email, etc. And these tests are in a format where you have given certain criteria, when the action happens, then a certain outcome comes. It is readable for business people, but at the same time, developers can automate it. So you can use AI to actually automate your specification, which saves a lot of time when you are validating the work from your colleagues in development. Okay, next tool I would like to show you is V0. It's from Vercel. It costs about $20 per month. I use it as a tool for prototyping. So every time I have some idea, I want to explain it to our UX designer. Back in the day, I was starting Miraboard and I was manually creating various boxes and drawing screens and so on. V0 is a tool that can build interfaces for you, and it works quite well. So I don't know, build chat face where users can speak with AI. And it's very similar to large language models, but the big difference is that this builds a real interface. So it's not like DALL-E or other tools, but it really builds interface. So your developers can take it, they can iterate on it, and so on. So preview is being created. 1 second. And soon we will see the screen. Okay, and now we have a chat with AI. So we can say something, we can send it, the AI will answer. Now I can say, okay, add a share button. And it will add a share button. Then we can add side panel and so on. You get it. So basically, this tool is perfect when you are prototyping ideas and you have an idea in your mind how it should look like. And this is quite a good way how to build interfaces that are interactive. So you can add multiple tabs, you can add links, data grids. These data grids can be sortable, filterable, and so on. So, and the code that it creates is decent. Sometimes it breaks. I don't use it here. Share conversation has been added, and see, it generated a random link. So it's quite good. I would not just copy paste the code it generates. Sometimes it's fragile, but for example, when I speak with my UX designer, it's perfect. It's very fast way how to explain what I expect from him. Okay, so this is V0. Now let's continue. Okay. So now we are getting to the point that will be a little bit more technical, but I will try to keep it still, let's say understandable. So one thing, what everybody is saying, everybody is doing is integrating large language models to the product. Honestly, yes, you should do it, but it's not going to give you any competitive advantage over others who are doing it because everybody is already doing this. So yes, it's worth it, but I will be focusing today on other things, not just letting users to chat with your application. And these can be things like personalized conversions from leads to users, personalized user activation, where new users, you need to convince them to use your application more, upselling, or for example, adding value by adding new forms of machine learning that are not large language models. So a side note, this field is huge. It's extremely huge. Personally, even my field was let's say optimization, that is more analytical, like linear programming, which, for example, helps in logistics and warehouses and so on. But in my life, I have trained less than 5 neural networks, which is a massive field. And even in neural networks, you might have people who focus the whole life on just a small subset. So I'll give you a couple of examples, but this list is by no means exhaustive. And if you will dig into it, you will find significantly more use cases. For example, today I'll not be speaking about computer vision. So you might have robots that self-navigate and so on. Okay, so some examples that might be useful for product managers or people who are building products or specifying products. So sentiment analysis. So net promoter score gap. If you have access to what people say about certain products, you can scan sentiment of people. And if you see that, for example, people speak negatively about particular part of a group of applications, you might be, let's say, a new player who will focus on that one aspect. Like if all applications in some field are ugly, you can build application that's beautiful. If all application in certain field have really bad integrations, no APIs, etc., you can build application that will be integrated with the rest of the ecosystem, for example. You can come up with ideas like if you will have access to something like Google Maps comments, so list all restaurants that don't deliver and have positive comments. You can build a startup that will just be delivering food from restaurants that they don't deliver themselves. Next one is Markov chains, which is great if you want to basically simulate behavior of users. It is trained on true users. So if you have people coming to your website or your product, you can use Markov chains to simulate them. So you can, for example, use this to see if a certain change will make workflows in your application faster. Kalman filters are a way how you could predict future, like next state in a noisy environment. And so Markov chains and Kalman filters have one advantage. They are not neural networks. Neural networks are the heavyweight in machine learning field. And the advantage is that they are the most powerful. But the disadvantage is that they are the hardest to reason about. So potentially you can teach them anything or almost anything. Like what you can see in the past year or two, it looks like they can be taught practically anything, making art, whatever, and making music. But they are very hard to explain, very hard to debug. So it will take a while for us to see, I don't know, neural networks that will be surgeons, for example. Markov chains, Kalman filters are significantly simpler and more predictable. So for the same inputs, you always get the same outputs. You can explain the structure. You can debug the applications. They are faster to train, faster to use. So not everything in machine learning are neural networks. There are other fields, even I would say statistics fall into machine learning field. Then there is Bayesian optimization, which is in business criminally underused thing. So Bayesian optimization is an algorithm. There are tools you can use Bayesian optimization easily. It can be integrated to almost any product. So when you optimize something, but each attempt costs you time, costs you money, so you can't run millions of experiments or thousands of experiments, and you want to do few experiments and you want to optimize, Bayesian optimization is great because it is mixing your optimal cases, like the recommendations, with let's say more exploratory attempts. So for example, if you have some pricing algorithms that you don't want to lose many customers, Bayesian optimization is great at testing and finding what customers react to, so you can maximize pricing to maximize your margins while not losing too many customers. Then there are neural networks, which basically are the heavyweight, as I said. They, for some input, give you certain output. There are many types of neural networks. One of those that are a little bit my field are Bayesian neural networks that for certain input give you not only output, but they give you also certainty. So you can use those networks to say, okay, for this input, the output is normal neural network will say, okay, it's number 10, like ideal price 10. But Bayesian neural networks gives you also the certainty. It's the mean is 10. 50% certainty that the optimum is 8 to 12. 75% is 6 to 14, for example. So Bayesian neural networks help you to also understand how far you might be from the optimum, for example. Then you have large language models. I suppose all of you are already using them. Where I think, again, what is underused at this moment is letting large language models to use tools, which will change very soon. OpenAI will release Operator. It is already available for people who have Pro. Plus Claude as from Anthropic, they have also a tool that can use your computer. So basically these tools will be able to do work. They will be agents that can use any application on your computer. Okay, so now, yes, before this, I would like to show you a couple of examples. So I built 3 examples for you. So first one is that Kalman filter. One sec, I will make a bit larger. So Kalman is for prediction. So what I did here is I have built, let's say, a radar. So let's say the airplane, red one, green one, and blue one, is the real position where the plane is. Then the circle is the measurement on a radar, but the radar is scanning the sky only every 5 seconds, and also it has certain level of noise, which means it is not 100% accurate. And then Kalman estimate is basically an estimate of where the plane is. So basically, as you can see, even with noisy data, the Kalman filter is quite good at predicting where the plane is. Of course, you don't have to use it only if you build radars, but this can be used to in any noisy environment where you are not scanning the data all the time. You are perfectly happy with some level of prediction. Here it is really off. But it got back. Okay, so this is the first example. Let's show the second. So the second is Markov chain simulator. Okay, so here in a factory, we have 3 lines, 3 manufacturing lines, red line, blue line, and green line, with 3 machines operated by 3 people. And you can see sometimes there is a change in manufacturing, sometimes the machine is broken. When you have all data from your process, from your machine, yeah, and here you can see the simulation is running, so, or it ran for 30 days. This is based on some historic data, and then you can do various what-if analysis. For example, what will happen if Alan will work on blue line and Arthur will work on red line? Because you are scanning how long does it take Alan to change the the parts to manufacture something else, or how often machine breaks to alarm. So you can just easily run what if analysis. And this is an example. Okay, and the last one is Bayesian customer learning. So this is Bayesian optimization. So let's expect that we have some e-commerce store, and we have 40 customers who will come, who will buy some product. And various customers react to different things. So, for example, price sensitivity of this person, how much this person reacts to emails, to recommendations, and the algorithm is automatically trying various prices. And here the customer purchased, this one did not purchase. So it's automatically learning what's the optimal price for the product. And in each iteration, the model is retrained again and again and again. And the good thing is that this might never stop. You can always continue. So with each customer, your model can evolve. So if the behavior of your customers will change, your pricing will change as well. You don't have to just train on a data set you have, put it to your application and keep it there forever. You can have a model that reacts to customer immediately. And this was based on quite random data. So this shows like here, the revenues for the customer went up and down. These zeros means these are customers who didn't buy. This is how the parameter importance or parameter evolved. What was their weight evolution? As you can see, it's all over the place because it was based on random data. So in normal e-commerce store, what you see here would be evolving towards some equilibrium where customers are this sensitive to discount, this sensitive to intensive emailing campaigns, and this intensive to, let's say, recommendations from others. So these are good examples of how large language, how Bayesian optimization might help you in your products. Then one thing, a quick side note. So one of the products we are building, our core product is Gitrivio, which is business intelligence software for CTOs, IT managers, and team leads. How we use machine learning in there. So one thing is generate one-to-one questions. So we are, you want to see the code. I can put it to GitHub and edit to the YouTube video if it's all right. Okay. So, basically, we generate one-to-one questions. So there are what people are doing on daily stand-ups. They track time. They take issues from some task software like GitHub issues and so on. And this generates one-to-one questions. The second is project blow-up factor. I will speak about this feature more, but basically it gives you a real estimate of how long things will take to be done. Next thing, AI workers to check methodology adherence. So for example, if people in the team agree that they will split tasks to be no more than 8 hours, AI can constantly monitor all team, and if in some team they will start having too large tasks and they are not splitting them to smaller ones, the AI worker or let's say some kind of bot can tell the team lead or IT manager about it. Then we are detecting non-development activities. Often these are important because they go under the radar, and when somebody leaves the company, suddenly people realize, oh, but this guy was actually doing job interviews with candidates or was onboarding new people, and because it's not coding, they didn't know it. So this detects non-development activities, or we have a dashboard to compare productivity of people who are currently onboarded to the team with people who were onboarded in the past, successfully and unsuccessfully. So you can faster recognize if a new team member will succeed or not. Now, I would like to speak about project blow-up factor, how this is actually implemented, because it's interesting feature. It is combining multiple types of machine learning. So, this will be a little bit mathematical, but it's not so much. So, when you look at how long things take, the reality is that when you estimate it will take, I don't know, 5 days. It might be 5 days, it might be 7 days, it might be 3 days, sometimes it's 20 days. So there is a statistical distribution called log normal distribution. So let's say this one, for example, the green line. So let's say we estimated it will take 0.35 year. And this is the mean, that's the middle point. And let's say there is 25% chance that it will take only 0.1 year, but there is also 25% chance that it will take 1.5 years. And knowledge of log normal distribution gives you much better decision-making, let's say, tooling, because you know, okay, if the risk is so high, and if there is still 25% chance that it will be 1.5 years, it's not worth investing money to building this feature. It's not must-have thing, so maybe we can deprioritize it. But how would you calculate a project blow-up factor? Especially, for example, if in your product you have plenty of different features, some of them are way more risky than others. So first thing is we tag all projects. So when you take a specification, you can use tools for tagging data. So you can run it through Google Cloud Natural Language API, Amazon Comprehend, or through normal LLMs, and these will give you a list of tasks, tags. And the good thing is about tags is that you can give it a list of existing tags, but you can tell AI, and we have used this. We have used this multiple times in different apps. These are existing tags. Try to use existing tags, but if you need, add more. And LLMs are really good at this. So first thing is, for each task, for each project, you tag it. And then you can train a model for each tag. So if you believe, or more or less, if you believe the tasks are in log normal distribution, which more or less they are, you need to turn them into this form. So you need to transform to normal form, which is simple. It's just like one equation. You compute the middle. So let's say in these tags, the middle of all tasks is, for example, 5 days. So if you get a new estimate, which is 2.5 days, you multiply it times 2 to get to the mean, and then you need standard deviation, which is, if you have seen this, it's a number, sigma equals 10, sigma equals 3/2, and so on. And so when you have all those tasks and you transform them to normal form, compute the mean, compute sigma, you can have a model, and it's very easy to train a model for each combination of tags, as long as you have enough data points, which is easy for tasks, which is more difficult for projects, because when you are doing any machine learning, I would say always try to have at least 100 data points. So let's say start with, for example, a model for each one tag. Then when you have enough data points, you can train a combination of 2 tags, for example, and then you basically apply the estimate to this mean and sigma, and it gives you exactly this estimate of the interval. Let's say, okay, I have this level of certainty, so this is the medium. So 75%, 50%, etc. And so that's the whole algorithm. It's not so difficult. The things I am speaking about right now are actually like 200 lines of code, 300 lines of code. Even those things I have shown here, for example, Kalman filter, the airplane, the radar. So the whole thing is just 200 lines of code. And you have some machine learning, which is significantly easier, significantly faster than neural networks. So one of the things I would like to say, and one of the takeaways you should have from this presentation is do not be afraid of machine learning. It's not like it is complex, especially because it's huge. And I am focused on one subset of all this. There are people who are focused on completely different things and they do their own things. For example, there are ways how to solve the same thing in many different ways. Like, for example, when I was speaking about Markov chains, you can use Markov chains, you can use neural networks. These will be more accurate, but harder to train, harder to explain, for example. But you should not be afraid. Plenty of those things are quite simple for implementation. As long as you know what you want to get, it's not so difficult to implement it. Now, I would like to say what I think is the future for AI in products. So large language models, everybody is implementing them. Maybe overuse is a little bit too much, but basically, yes, everybody will have them. They will be everywhere. You should have them, but having them will give you no competitive advantage because you need something more. While other forms of machine learning, like the sentiment analysis and other things, are underused. They are going to be underused because they are not part of the hype. So I think you should focus on like what machine learning itself can give you, not just one part of that. Then what I think will happen is everybody is focusing on white collar jobs, automating office jobs where text is input, text is output. So there are already billions of dollars coming there. Where there are not is blue collar jobs, niche, either a country, certain language, etc. And between domains. So when you have CRM, you can bet that your CRM will have LLM. You can have lead gen software that will be sending cold mails, and you probably already use something that can create cold mailing messages. But what about things in between? For example, activation of early customers. As far as I know, nobody is doing this because it's between the web app and the CRM. So you need to build it yourself. This is where the opportunity lies. Next thing, two technologies or two things I would like to recommend to monitor. Both of them are from NVIDIA. One is Metropolis, which is more connected to those blue collar jobs. Basically, it's a toolkit which you can use to build robots and video analytics and so on in warehouses, logistics, things like that. It is featureful. Next thing is Project Digits. So Project Digits is not available yet, but it's basically AI supercomputer anybody can buy. It will cost around $3,000. It will be available, I believe, in May. In different countries, it might cost different money, but let's say $3,000 plus. And this machine will be able to run 200 billion parameters models, which is a lot. And the cheapest what you can buy if you will buy, let's say, 4 NVIDIA 390s or 490s, it will cost you at least twice. And you can buy this box and it will cost you $3,000 and you can run your large language models or other machine learning models in your on your table. So once it will be available, I'm definitely buying this. I am not affiliated with NVIDIA at all, but this is going to be really a huge opportunity to save money and to have some machine learning machine at home. Um, Now, a couple of other key takeaways. So, use different forms of machine learning, go beyond the common ones. LLM is great, everybody has it. Process data about competitors, customers, users, colleagues, just put them through some models. It's not so difficult. A good thing is, even the other forms of machine learning I have shown you uh, are uh, are doable even when you are not a developer. You can actually write code with AI and it's decent. It's good to have somebody who can give you a feedback, who can review your code. In Flexiana, we have a colleague who studied machine learning in Oxford University. He has a patent and so on. So I can ask him for feedback, but you can always try to find in your neighborhood or somewhere online on LinkedIn if there is any person who knows machine learning to give you a feedback if your model is right. Another thing is you can always generate synthetic data and you can validate that it works. It's not so difficult. Again, ChatGPT can help with that. Um, ChatGPT and other large language models are also great to tell you about existing forms of machine learning. So there are random forests and like there's so much. I haven't shown you even 1% of this field, but these things are actually quite supported. There are plenty of open source libraries you can use, which you can embed into your products or into your workflows. It's cheap to implement them. You don't have to use like early stage startups. Most of them are going to fail. Most of them are basically wrappers over a library. So you can embed those things into your ecosystem directly. If in your company are taking this seriously, it might be worth having somebody who is excited about machine learning and have something like chief machine learning evangelist uh, who will bring those ideas and engage with people in the company to help the implementation of this. One thing I would like you to remember is machine learning. It's better to use easier, simpler algorithms because they are easier to debug, explain what they are doing, they are more predictable. So, for example, if you are moving money, working with health data, and so on, it's better to use as simple systems as possible because you will have fewer bugs. Um, and neural networks are the most heavyweight thing, and large language models are the heavyweight of the heavyweight. So these are great, but try to use simpler models as well. Great. So I would like to thank you, and now it's a time for questions. So feel free to share your questions. Besides that, so this is my email if you had any questions. Also, we have a YouTube channel, youtube.com at flexianadev. The recording of this webinar will be on Flexianadev YouTube channel. I will add the source codes, the links to everything, including the presentation. So I hope you enjoyed. And by the end of February, we will be running a next section. So hopefully, see you next time. Yeah, Peter, blow up analysis. Could you explain again the input? Yes, sure. So input. Okay. So we can have a list of tasks. Yeah, thank you. So we can have a list of tasks, for example, for to-do list up. And then we might have like a task. Yeah. Add a task, etc. So read the task and so on. And then you can take all this and you can ask AI to tag it. So, okay, please take tags for each task it to. Yes, and like this, I have created tags. So for projects, you might have tags that are, for example, using API, using external data, sharing across multiple users, and so on. So you can tag your data, and then you have estimates. So for example, this is 8 hours, this is 1 hour, this is 2 hours. And the blow up factor is basically, okay, I have this 8, and for tag add, actually, we know that it is this multiplier and this sigma. So it would be actually 8 might have multiplier 1.5. Yes, if you have any specific issues in your company, you can schedule a call with me. So blow-up factor would be, for example, 1.5, and for example, 75% certainty will be from 12 will be 10 to 14 hours, for example. So this is what you arrive to with this model. So I hope it helps, Peter. Okay, then. So if there are no more questions, I would like to thank you. It was great that I've got a chance to show you what I have been working on, and hopefully see you again by the end of February.